So, so my IP address is this. You can see.
Yes, sir.
So why this is happening? Because this IP address is the public IP address. So our institute has purchased 64 public IP address from BSNL and 16 IP addresses from NKN or National Knowledge Network. So this is National Knowledge Network IP address, okay? And our private IP addresses are not visible outside, okay? So and then there is a device, there is a miss here you when you were here you used to select a proxy server, no, to connect to internet. So you are connected to a proxy server. So proxy server IP you set up in your browser that 172.3100.14 or something like that. So your connection is terminated at proxy server, and then your source IP address is changed. Okay, so my source IP address, whenever I communicate to internet, or right now I am communicating to you guys, so my source IP address is this, but it is translated to this public IP address because on internet this private IP address has no bearing. This private IP address is not recognized outside. So IP addresses are divided into public and private IP addresses. There are classes, okay, and only public IP addresses are kind of uh, you can say can be visible or can be recognized when you are on public internet. Within our institute, I can use this private IP address. Every student, every laptop is having a static IP address of 172.31 range, but these IP addresses need to be changed when you try to send data out of the institute. So similar thing is happening with Bharti Airtel or Reliance Fiber or Geo Fiber. Uh, they give you a private kind of IP address, which is for your purpose because you require one identification inside. Otherwise, what would happen that suppose I don't want to have this type of mechanism, then I need to give each and every user of institute a public IP address, which is going to be a very costly affair. So that's why we purchase few private public IP address, and inside we use private IP addresses, few public IP address, and we use those public IP. It's a kind of multiplexing which is happening, that the data of all the private IP addresses is riding on few public IP address. Are you getting the point, Tanmay?
Yes, sir. Yes, sir.
So this is what might be happening in your case also. Fine. Any other doubt? Okay, if there are no more doubts, then we can. So let me start the recording first. Recording. Somebody has started recording, I suppose. That's good. Okay, fine. So let us continue our discussion of the devices, and we have seen. I believe we have done with. We are done with repeater, and hub. Fine. Repeater and hub are done. Now the next device which we are going to discuss, so let me draw one small topology. So suppose this is one hub which is connected to say another hub, and this topology I have drawn in the previous lecture. So this is hub 1 and this is hub 2, and here some nodes are connected. So suppose node number A, B, C and D are connected, and here E, F, G, H are connected. Have I discussed about the bridge, Abhigyan?
Yes, sir.
I think I have discussed. So
Yes,
this
sir.
is done. Up till bridge we have done. So I remember I have drawn a bridge in between, remember?
Yes, sir.
And then there were two ports of the bridge, port number 1 and 2, and then we can break the collision domain. I remember now. So we have discussed the concept of collision domain. Yes. And then using bridge, we can break the collision domain into two parts, because if we want to transfer data from D to A, then bridge will block the data to transferring from uh, this side. So the data of ABCD can collide with the data of ABCD only if your transfer is happening in this side, and vice versa on this side also. Now the next device which we are going to discuss is which is known as multi-port bridge. Multi-port bridge, or another name of this is switch. Commonly it is known as L2 switch or layer 2 switch. So what is L2 switch? So let me describe the working of L2 switch first of all, and then we'll see the more advanced versions. So it is having multiple ports, and if you see nowadays networking, this L2 switch is actually connected to your devices, ports, systems directly. A, B, C, D, E, F, and so on. Now, similar to the bridge, what is there in L2? L2 is having its own small operating system, algorithm, and everything. So, what is happening in L2 switch? There is a MAC table. Normally, it is known as MAC table, or you can say switching table. It is having three fields. One is your port number. Other field is your MAC address, and third field is your TTL. And how long this entry is valid. So these are the port number 1, 2, 3. I'm just giving you a generic explanation. In many switch, you might see the port number as there are some standard name Eth1 or fast Eth1 or GH1, depending upon whether it's a normal Ethernet, fast Ethernet, or gigabit Ethernet. Fine. And then 10G Eth1, these type of name are also given to these ports. Fine. So now what is happening? This switch can be configured that okay, port number 1 is connected to MAC of A, MAC address of A machine. Port number B is connected to MAC of B. Port number 3 is connected to MAC of C. And then we can have some TTL of 60-second. Depending upon the configuration, you can set up the TTL also. Fine. So now what is happening here? Suppose A wants to transfer data to C. So the outermost header of A will be Ethernet header, and which will be having source MAC and destination MAC. So when A want to transfer data to C, the source MAC would be of MAC of A and destination MAC would be of MAC of C. When this packet reaches to switch, because A will transfer data to switch, switch is a store and forward device. So the outermost Ethernet header will be extracted, and this field will be red. Destination MAC field will be red. And this destination MAC field will be compared in this table. So here the destination MAC will be matching with this entry, and then you come to know that okay, switch need to transfer data to this port, and through this port data can be transferred to the. So here in this setup, once this table is populated, how it is populated, how this table is populated, I'm just coming to. So you can see here that once this table is populated, there is no question of collision. Is there any question of collision? Can there be any collision? Anybody? Yes, Abhigyan?
Sir, if C will send at the same time.
If C will send at the same time. So then we need to think about the wire through which it is getting connected. As I told you, we use Cat5 or Cat6 cable where there are 8 pair of wires. Fine. So there are different TX transmission and RX lines, receiver lines. So there are 8 pair of wires. So there would be no collision. Suppose A and C are both sending to each other, still there would be no collision because they would be going to using different set of pairs. Okay? Okay, Karimullah?
Okay, sir.
So there would be no question of collision. So in fact, if we have a network where at the last mile the nodes are connected directly connected to a layer 2 switch, uh, that particular network does not need this CSMA carrier sense multiple access and collision detect. So there is no question of collision. So there is no collision actually if you have layer 2 switch equipped network up to the last mile. Now you may ask a question, sir, there is no question, then why we are still saying that it is Ethernet, that it is so there is a new name given which is known as switched Ethernet. Switched Ethernet, where actually there is no role of CSMA and CD. But because we are using the traditional MAC address to solve our purpose, it is known as, still it is known as, because we are opening the Ethernet header to do our work, it is still known as Ethernet. Having said that, uh, there is no working of CSMA-CD here because we are not doing carrier sense multiple access with collision detects. It's a kind of shared media but controlled by a layer 2 switch that there is no point of collision. It is micro segmentation of LAN. So there are different collision domain and there is no collision. But because we are using Ethernet header, we are using one very important field MAC address of Ethernet header, and that's why it is known as switched Ethernet. So if somebody asks you a question that whether we use CSMA CD nowadays or not, so you need to answer this that, okay, if there is a switched Ethernet up to the last mile, actually there is no use of CSMA CD. It is known as Ethernet only because uh, we are using MAC addresses which are part of the which is because of the Ethernet protocol, traditional Ethernet protocol. Due to traditional Ethernet protocol, MAC address came into picture, and we are using the MAC addresses still to solve our purpose to forward the data, because the data forwarding is happening on the base of destination MAC address, and that's why it is known as switched Ethernet. But we are not using carrier sense multiple access with collision detect anymore. Any question in this discussion? Yes, Abhigyan, Tanmay?
No, sir.
Clear?
So if both A and B are sending packets at the same time, then
To each other?
I mean, no, not to each other, to different port, let's say to F.
So there is no problem because switch is having different ports and paths for that. Okay. Just a minute, I have to take this call. आशीष क्लास में हूँ अभी. 4:30 फ्री हूँगा. 4:30 नेटवर्क लैब वाले केबिन में हूँ मैं. ठीक है. ओके ओके. तुमको बैठना हो तो आके लैब में बैठ सकते हो. Fine. So there are different ways here. So there is no question of collision. There is memory, there is buffer, so packet will arrive, packet will be stored in a buffer. Okay, inside switch, there is no question of collision. Okay. Jatan
Yes, sir.
hmm?
Yes, sir.
Any other
So, but
doubts?
who will go first, A or B, like if both are sending at the same time?
Who
Or
will
will there
go?
be a delay?
Look, that depends upon. Look, I told you that there is a queue. There is going to be a queue at every port. No, fine. So switch will process the packet. That depends upon the computation power of the switch. Actually, if I go by the internals, so there is a backplane actually inside a switch. Fine. So and there are different types of backplanes that how to switch the data from one port to another port. So when we discuss what is inside switch, you'll be more clear about the thing. But you can say that there are buffers at every I/O port. Fine. And depending upon how many cores are there in the switch computation unit, so these packets will be transferred. Fine. So what is happening actually that inside a switch, similar to our you know about instruction level parallelism, Tanmay?
No, sir.
Pipelined architecture,
Yeah.
huh?
Yes, sir.
So that is instruction level parallelism. Okay, so you know about this thing, no? That there is a fetch cycle, huh? Then
Yes, sir.
decode cycle, then execute cycle, then write back cycle. So they, and when we have a pipelined architecture, fine. So a instruction will come. So when first instruction is getting fetched, uh, when first instruction is getting decoded, next instruction can be fetched. When first instruction is getting executed, the next instruction can be decoded, and first another instruction can be fetched. Are you getting this point? This is how
Yes, sir.
pipeline work. So similar to that, we have a pipeline here in switch also. Fine, depending upon what are the different tasks which have to be performed over this packet. So this is again a pipeline architecture of switch where you in first step you might be extracting the header, in second step you might be reading the MAC address, the third step you might be comparing the MAC address, and fourth step you are taking the decision which port to forward. And then this is happening inside the switch architecture. So once the packet is received at the switch, now it's the work of the switch computer. When it takes the decision, again, when you want to forward the packet to port number say 6 and still one packet is getting forwarded, depending upon the transmission speed of this link, told you transmission time. Okay, so this packet will be buffered, the packet which is ready to be transported. Similarly, if any packet is getting uh, executed inside switch and another packet is coming from any port, that has to wait in an input queue. Are you getting the point?
Yes,
So
sir.
there would be two queues. Suppose we take two ports. Suppose there is a port number 1 and there is a port number 2. And so because port number 2 is output port and port number 1 is input port, so you are saying packets are going from port number 1 to 2. Fine. So when a packet is getting processed, so another packet which are coming at port number 1 has to be queued. When one packet is getting transmitted, so another packet which is ready to be transmit has to wait in queue port input output queue at port number 2, and vice versa. Suppose 2 is both input and output. Fine. As per your suggestion, because both are transferring to each other, then again there would be two queues, input queue and output queue. Got the point?
Yes, sir.
Okay. Any other question? Now let's see that how this table is populated, how the switch table is populated. So let's assume that there is a 4-port switch or 5-port switch, and These are the nodes which are connected. So I am just giving you a very basic explanation of self-learning switch. Self-learning switch. And we can assume that this switch has just been powered on. Okay, has just been powered on. So right now the MAC table is empty. Say port number, MAC address, and TTL. There are no entries. It is empty. Now what will happen? Suppose A wants to transfer data to D, say. So packet will come at switch through this port number 1. Now switch will extract the destination MAC address, means MAC of D will be extracted because A wants to transfer data to D. So at destination MAC field there would be MAC address of D. Switch will go and inquire its table, will find no entries here, will find no entries here. It is completely vacant, completely empty, not populated. Then what switch will do? Then there is no option in front of switch but to flood the packet to all the ports. Now switch at this point of time cannot do anything but to forward this packet to all the connected ports. So for this particular time, switch will behave like a hub. For this particular time, switch will behave like a hub, will be forwarded to all the port. But switch will do one thing. Because when this packet from A has arrived at switch, this packet was having source MAC address also, which is MAC of A. It's another thing that switch could not find destination MAC address in the table. That's okay. But this packet has arrived from A. A is connected to port number 1 of switch, and A source MAC address is now known to switch. So what switch will do? Switch will populate this table that okay, port number 1 is connected to MAC of A. This is the self-learning behavior. Okay, now D will receive the packet and now D will try to send the reply. Suppose D tries to attempt to reply. Now D will send the packet. So D will be having as source MAC address MAC of D and destination MAC address MAC of A. So first of all, destination MAC address will be extracted and it will be compared in the table. And now there would be no flooding because you can know that MAC of A is connected to port number. So the reply of D will be directly transferred to port number 1. But side by side, what switch will learn, because this D's packet is coming from port number 4 and D's packet is having source MAC address also. So now switch can learn that port number 4 is connected to MAC of D. So slowly and gradually, as nodes transfer data to each other, switch can learn about the MAC addresses which are currently connected to switch. And these entries will be considered valid only up to this time to live time, which generally is 3 minutes by default. You may change the setting and reduce it or do that. So in this way, switch can self-learn about the ports, and the ports are connected to which MAC address can be self-learned. And slowly and gradually, this table can be populated. And after the table is populated, then there is no question of flooding. So simple one-to-one transfer will begin. Any doubts?
Sir, these ports are different from the ports from transport layer, right?
Obviously, transport layer port is a logical port.
Okay,
These
this is
are the
from the ports
this
of
is
the hub,
thi-
sorry, switch
this
only.
these are the hardware ports.
Okay, okay.
Sir, you said that these entries are valid only till time to live time.
Yeah.
So, sir, but later also the port which is having like port 1 is having MAC address of A only. So
Hmm.
it should be valid for lifetime, like once it is filled.
नहीं, कैसे तुमने उठाया दूसरे पोर्ट पे कनेक्ट कर लिया? हाँ?
अच्छा हो चेंज कर सकते.
ठीक है, तब तो फिर गड़बड़ी हो जाएगा. ठीक है.
सर
और
डिवाइस से स्विच तो उसके
अभी
पोर्ट्स तो मतलब
अभी तो
इंटरचेंज.
बच्चा मैंने बताया ही नहीं कि एक और कांड हो सकता है कि इस स्विच का जो पोर्ट है वो एक वायरलेस एक्सेस पॉइंट से जुड़ा हुआ है, वाईफाई राउटर से, जहाँ भाई लोग आ रहे हैं जा रहे हैं. क्यों भाई?
यस सर.
ठीक है, तो इसीलिए टीटीएल जरूरी है. ठीक. और किसी को कुछ पूछना है? स्विच देखा नहीं क्या कभी? स्विच देखा है कभी फिजिकली? ध्यान है स्विच कैसा होता है? 1 मिनट रुको. अच्छा देखो, मेरे पास होगा तो मैं दिखाता हूँ. 1 मिनट रुको. ये दिख रहा स्विच? 1 मिनट. दिख रहा बच्चा लोग?
यस सर.
हाँ,
Yes.
ये है,
यस
ये
सर.
सिस्को का 2960 है. ये हमारे इंस्टीट्यूट में लास्ट में लगा हुआ है. इसमें देखो पोर्ट्स दिख रहे हैं आपको. इसी में ईथरनेट केबल कनेक्ट होती है. ये जो पोर्ट्स हैं, ठीक है, ये डिफरेंट पोर्ट्स हैं स्विच के. यहाँ से केबल निकलती है, फिर आईओ पोर्ट में जाती है. आईओ पोर्ट से आप अपना सिस्टम कनेक्ट करते हैं. ठीक है बच्चा लोग? और ये अपना एक पूरा सिस्टम है, कंप्यूटर है. पीछे पावर केबल लगती है, ठीक है, फैन लगा हुआ है. और ये चूंकि बहुत सोफिस्टिकेटेड स्विच है, तो इसमें देखिए आप इधर अगले स्विच को कनेक्ट करने के लिए भी पोर्ट हैं, जिनको हम अपलिंक पोर्ट बोलते हैं, कि इस स्विच से दूसरा स्विच भी कनेक्ट हो सकता है. क्योंकि एक ही स्विच तो चलेगा नहीं, कई अगर सब 100 सिस्टम की लैब है तो आपको स्विचेस को स्टैक भी करना पड़ेगा, तो इससे कई स्विच भी जोड़ सकते हैं अपन। 24 पोर्ट के 4 स्विच जोड़ेंगे तो 96 पोर्ट की लैब बन जाएगी, ठीक है, जहाँ पे 96 कंप्यूटर अलग अलग कनेक्ट हो सकते हैं। ठीक है बच्चा लोग, अभी समझ में आया पोर्ट क्या होता है? दिव्यांश?
यस सर, यस सर।
अब क्या बताएं, तुम लोग यहाँ हो ही नहीं यार, कोरोना ने सब ऐसी तैसी कर रखी है। नहीं मैं इसको तुमको कॉन्फ़िगर करके दिखाता।
सर ये किधर लगा होता है, मतलब हमारे हॉस्टल्स मतलब कॉलेज में?
हाँ बेटा, ये आखिरी में लगा है तुम्हारे विंग में। विंग के बाहर एक रैक लगा होता है ना, देखा तुमने अपने हॉस्टल विंग के बाहर कहीं कभी देखा?
एक फ्लोर पे एक मतलब बॉक्स रहता है बड़ा सा।
एक बॉक्स रहता है, उस बॉक्स के अंदर ये स्विच अंदर रहता है। उस स्विच से ही अंदर अंडरग्राउंड केबल्स गई हैं आपके कमरे में, जो पोर्ट लगा था आईओ पोर्ट, जिससे आप कनेक्ट करते हो अपना इथरनेट केबल।
ओके।
ठीक है, और कुछ पूछना है किसी को?
और सर एक डाउट,
हाँ
सर इस तरह की कॉन्फ़िगरेशन में मतलब जब तक सारे कंप्यूटर एक बार तो किसी और को कम्युनिकेट नहीं करेंगे तब तक उसे हर
Obviously.
किसी का,
ऑब्वियसली
तो सर हम एक लीनियर सर्च क्यों नहीं मार लेते?
इनसे पूछ लें कि तुम कहाँ हो।
हाँ सर।
मतलब तुम चाहते हो कि स्विच खुद पूछे सबसे कि भाई इस पोर्ट पे कौन है, इस पोर्ट पे कौन है, इस पोर्ट पे कौन है, यही
काइंड
कहना
ऑफ, क्योंकि सर कनेक्टेड है तो हाँ एक बार अगर
यार,
लीनियर सर्च हो
स्विच
जाए।
को हम सिंपल बनाना चाहते हैं, ठीक है। ठीक है, स्विच अभी तुमको जो बताया है मैंने वो एक सिंपल स्विच का कॉन्फ़िगरेशन है। दैट्स मोस्ट सिंपलिस्टिक आर्किटेक्चर आई हैव एक्सप्लेन। And what I'm saying that there may be sophisticated switches ki as and when you connect, your MAC address will be known to that, even if you send anything or not. And if it is not connected, they are not sending anything, still when you connect any system to network, that system will send some packets. As I was telling to Pranavi also, that even if you are not surfing web or doing anything, some of the packets are getting sent by your system towards the network for different management and for different purposes. So it is less likely that until unless your port is empty, fine. So if a system is connected, system will be sending something. Okay. ठीक है लवदीप?
जी सर।
सर जैसे आपने कहा कि वाईफाई लगा हो सकता है, सर वैसे ही किसी पोर्ट पे सर
स्विच भी लगा
हब भी
सकता है, हब भी लगा
हब
सकते
भी
हैं।
लगा हो सकता
यस
है। तो
यस
सर
लगा सकते हैं।
फिर
आप
डेस्टिनेशन मैक
खुद
एड्रेस क्या
बताइए, आप
रहेगा?
कंप्यूटर साइंस पढ़ रहे हैं, फिर आप खुद बताइए। मैं अगर कहता हूँ अब इसके आगे तो लॉजिक ही लगाना है बच्चा ना। इसके आगे तो सब कुछ लॉजिकल है। सपोज आई से दैट देयर इज ए स्विच, L2 switch, which is connected to another switch, okay, and port number 1 and port number 2 and port number 3 and port number 4. Now you can think of any possibility which is connected to hub, which is connected to wireless access point, and this is connected to another switch, L2 switch. Fine. So this may be having wireless node, say H1, sorry, control Z. Should not say H1. Okay, suppose this is having A, B, C nodes which are wirelessly connected. This is having E, F, G which is connected to hub. This is having H, I, J, K, these nodes. So now you can see, if we go and check the table of L2, the L2 table port number 1 would be mapped to H, I, J, K. Port number 2 will be mapped to E, F, G. So instead of one entry to one port, we can have multiple entries to one port. Got the point, Tanmay?
Yes, sir.
So now you can see it's a table, no? Data structure. It's a management information base actually. So depending upon, it's not like that one port can be mapped to one MAC address only. If you want to extend the topology, then you need to provide the MAC addresses. Okay.
So you didn't mention about there being a switch. You can connect basically two switches.
Yes, you can connect.
Okay, so sir, I am assuming that all of them will have different switch tables.
Obviously.
Yes, sir. So it takes about 3 minutes to populate one switch table.
Who says it
And
takes 3 minutes to populate one switch table?
you said that it's default.
3
that
minutes
it,
is a TTL.
oh, okay,
It
sir.
takes 3 minutes to delete that entry, and you can change that 3 minutes. Okay. So that's a time to live up to how long this entry will be valid. Okay.
Okay, sir.
Mm.
Alright, so if let's say that one switch has 24 ports, and obviously that we have switches in our college, we have series of switches, because obviously there are more than 24 students and 24 ports. So it should take about, तो मुझे अगर लेट्स से मुझे एक स्विच से दूसरे लाइक मुझे किसी को भेजना है डेटा, तो पैकेट भेजना है, तो फिर मेरा जो स्विच से कनेक्टेड है एंड जैसे मुझे भेजना है वो दूसरे स्विच से कनेक्टेड होगा, बट टाइम टू लिव तो 3 मिनट्स ही है, सो लाइक ये पूरा फिर से बनेगा। सो
बनता
इट शुड
रहेगा,
टेक
अलग अलग स्विच का अलग अलग बनता रहेगा, और ये स्विचेस आपस में बात भी करते रहते हैं। ठीक है, इसका
ओके
टेबल
सर।
में चेंज होगा कुछ तो वो ऊपर पता चलेगा।
सो इट शुड टेक अ लॉन्ग, लाइक अगर तो फिर मैं लेट्स से
नो,
पहले स्विच 1 पे हूँ।
नथिंग इज हैपनिंग एट डिस्क्रीट इंटरवल बच्चा। ठीक है, इट
ओके
इज
सर।
नॉट हैपनिंग दैट इज एट डिस्क्रीट इंटरवल एवरीथिंग इज हैपनिंग। यहाँ से नोड छोड़ के गया, ठीक है, दूसरा नोड कनेक्ट हुआ, इसकी टेबल चेंज हुई, जैसे ही टेबल चेंज हुई इसने इसको बता दिया, फाइन।
ओके
So
सर।
there are link local discovery protocol. There is spanning tree protocol. Spanning
Okay.
tree protocol. These switches are also talking to each other. Okay.
Okay, sir. I'm sorry, I was just not able to grasp how all of this happens so fast.
So just give me some time and give yourself also some time. Okay.
Okay,
You'll
sir.
be clear about everything. Fine.
Sir, thank you
सर
so much,
इससे
sir.
बेटर हम स्विच को मैक दे दे एक अपना खुद का।
हमने कहाँ कहा कि नहीं देते अपन। ठीक
सर
है,
मतलब सारे स्टोर करने के बदले वन का मैक स्टोर करेंगे अपन ऊपर।
हाँ, तो हमको कैसे स्विच का तो मैक स्टोर करना ही पड़ेगा हमको, बट स्विच के नीचे कौन कौन है ये कैसे पता चलेगा।
मतलब स्विच को भेजेंगे हम पैकेट वापस L2, मतलब जो
अच्छा
नीचे वाला स्विच है उसको
करीमुल्ला,
पता है।
तेरी बात मैं कहता हूँ, इधर L2 पे एक I कनेक्टेड है, ठीक है,
यस
और
सर।
उसको इस H को भेजना है, तो
ओके
L2
सर।
वो भेजेगा, I की एंट्री नहीं मिलेगी तो क्या करेगा,
ऊपर
अगर
भेज
H को भेजना है उसको, ठीक है, उसको H को
ऊपर
भेजना
भेज
है तो वो ऊपर भेजेगा। क्यों भेजेगा भाई, उसको क्या
हब की
पता कि ऊपर से जाके हमको H मिल जाएगा।
वो हर किसी को भेजेगा वो एज हब।
उसको हर किसी को क्यों भेजेगा, भेजेगा भी तब भी क्या फायदा। नहीं, ऐसा नहीं है बच्चा, L2 अपनी रीचेबिलिटी बता के रखेगा ना, ये भी तो एक पोर्ट है ना जिससे L2
ओके सर।
कनेक्टेड है, उधर से भी तो चल।
हाँ
L,
समझिए।
L2 का इसका भी तो एक ये पोर्ट नंबर है, ये कहाँ कहाँ रीच कर सकता है। तो अपन को स्विच का तो मैक एड्रेस पता चल गया, लेकिन ये स्विच आगे किससे किससे कनेक्टेड है ये भी तो पता चलना चाहिए इस पर्टिकुलर पोर्ट पे।
यस
Are you
सर
getting
समझ
my
गया।
point or not? So this is
हाँ
the work of MIB, Management Information Base. ठीक है, so ये इंफॉर्मेशन हमारे पास रहनी चाहिए, अदरवाइज अब सपोज इस L2 से एक और यहाँ L2 कनेक्टेड है, तो इधर तू भेजेगा H ढूंढने के लिए कि इधर भेजेगा, ये डिसीजन लेना पड़ेगा ना। तो मेरे पास यहाँ पे इंफॉर्मेशन होनी चाहिए ना कि H यार इधर ही रास्ते से मिल सकता है, तो ये कैसे आएगी, ये स्विच बताएगा कि मेरे इन पोर्ट पे ये मैक एड्रेस कनेक्टेड है, ये इंफॉर्मेशन इधर आएगी, तभी तो इस L2 को पता चलेगा कि नहीं अपन को पोर्ट नंबर 1 पे भेजना है, इस पे नहीं भेजना है। समझ में आया?
यस सर।
सो ये जो मैक टेबल है स्विचेस की, लॉजिक से चलो, क्योंकि लॉजिक से नहीं चलोगे अगर तुम अभी इंटरनेट पे ढूंढोगे तो तुमको सिस्को वाला कुछ और गाना गाएगा, ठीक, जूनिपर का कुछ और गाना गाएगा, ठीक, वो उनके इम्प्लीमेंटेशन के तरीके हैं। फाइनली तरीका क्या है कि यहाँ जो है भाई, ठीक है, वो हमको पता जरूर चलना चाहिए नेटवर्क में, ठीक, नहीं तो हमको मालूम ही नहीं चल पाएगा कुछ। और अभी तो हम केवल मैक एड्रेस की ही बात कर रहे हैं, अभी तो अगला डिवाइस हमने पढ़ा ही नहीं, अभी तो आईपी एड्रेस से भी तो जरूरत पड़ती है, उसी से राउटिंग होती है। कितना बड़ा जंगल आप बना सकते हो L2 का, एक लिमिट होगी ना उसकी, इनकी टेबल्स की साइज की भी लिमिट होगी। तो केवल मैक एड्रेस से ही नेटवर्किंग नहीं होगी, हमको आगे भी चलना पड़ेगा इसके, ठीक है।
यस सर।
और किसी को कुछ डाउट?
सर बेसिकली हम लोग टेबल जब ही चेंज करते हैं जब कोई रिक्वेस्ट आती है उस मैक एड्रेस से। अब अगर हम लोगों ने जो कनेक्टेड डिवाइस था उसे वहाँ से रिमूव कर दिया और कोई नया कनेक्ट भी नहीं किया है, तो जो एंट्री थी वो तो अभी भी है, और जो डिवाइस हमने डिसकनेक्ट किया था उस डिवाइस को उठा करके हमने किसी और पोर्ट में लगा दिया, तो फिर उसी डिवाइस की 2 एंट्रीज हो जाएंगी। तो क्या जो हमारा स्विच है वो दोनों एड्रेसेस पे भेजेगा, या फिर जो
तुम खुद सोचो, अगर वो मैक एड्रेस यहाँ से उठ गया, ठीक है,
यस सर,
यहाँ से उठा और यहाँ से उठ के भाग गया और यहाँ चला गया, ये मैक एड्रेस, ठीक है, यहाँ चला गया अगर, तो किसी एक की टेबल चेंज होगी ना।
सर बट मैंने यहाँ पे इसकी टेबल तो चेंज होगी L2 की,
हाँ।
बट मेरा जो लेफ्ट वाला L2 है यहाँ पे
तो L2 की टेबल जैसे चेंज होगी, L2 अपने से कनेक्टेड सभी भाई लोग को, स्विचेस को बताएगा।
यस सर।
और जब ये पता चलेगा कि ये मैक एड्रेस यहाँ पे आ गया है, ठीक है,
यस सर,
तो ये वाले मैक एड्रेस को वो हटा लेगा अपने इस पोर्ट से, ये वाला L2।
तो मतलब एक मैक एड्रेस को ये सिर्फ यूनिकली स्टोर करता है, कॉपी नहीं बनाता।
मैक एड्रेस खुद ही यूनिक होता है।
नहीं
एक
मतलब
मैक
अगर एक मैक एड्रेस
दो
किसी
जगह
एक पोर्ट
कैसे हो सकता है, तो खुद सोच। तो बड़ा सा एग्जाम्पल मत ले, एक ही स्विच लेते हैं, ठीक है, एक नोड A यहाँ कनेक्टेड है, उसने यहाँ से डेटा भेजा, ठीक है, थोड़ी देर बाद तुमने क्या किया, इस नोड को इस पोर्ट से हटा लिया, इस पोर्ट पे लगा दिया A नोड को, फिर तूने डेटा भेजा, तो स्विच को पता चल जाएगा ना, पुरानी एंट्री को पर्च कर देगा, ठीक है, नई एंट्री को कर देगा। और अगर किसी तरीके से नहीं भी पता चलता है तो 60 सेकंड बाद तो वैसे भी सब हट जाना है, ठीक है।
ओके सर,
ठीक है। सो इट्स लाइक, और जहां तक तुम जो क्वेश्चन पूछ रहे हो, वो क्वेश्चन किसी मामले में वैलिड भी है, कभी कभी ऐसा हो सकता है। तो डेटा या तो इधर जाएगा या इधर जाएगा, अगर एक की एंट्री हो गई तो दूसरी की नहीं रहेगी, ये मान के चलो, ठीक है।
तो सर इस प्रोसेस में स्विच को कुछ ज्यादा काम नहीं करना पड़ रहा, मतलब उसे ये भी चेक करना पड़ रहा है कि मेरा जो मैक एड्रेस
कर रहे हो पैसा भी तो खर्च कर रहे हो ना स्विच को लेने के लिए, स्विच खरीदा है तुमने, ठीक है, तो यू आर डूइंग दैट जॉब आल्सो, नो? यस और नो?
यस सर, यस सर।
तो भी तो काम अपन कर ही रहे हैं। यही काम ही है स्विच का ना, नहीं तो नेटवर्क चलेगा ही नहीं।
नहीं सर, मतलब हम लोग इसको ज्यादा ऑप्टिमाइज भी तो कर सकते हैं, बार बार चेक ना करें, और जो पोर्ट वैलिड नहीं है उसे वैसे ही हटा देते हैं। मतलब
कैसे पता चलेगा? तुम खुद सोचो, तुम खुद अपने आप से सोचना कि इसका और क्या तरीका हो सकता है। नोट तो मूव करेंगे, इधर भागेंगे उधर भागेंगे, आज तुम इस हॉस्टल में आओगे, कल तुम उस हॉस्टल में जाओगे, ठीक है, तुम इस कमरे में भी लैपटॉप अपना कनेक्ट करोगे, जाके लैपटॉप दूसरे कमरे में भी कनेक्ट करोगे, करते रहोगे ना ये।
यस सर।
तो ये जब करोगे हो तो तुम्हारी स्विच की टेबल चेंज ही होगी, ठीक है। और अभी बहुत सारी और चीजें बाकी हैं, केवल स्विच के लेवल पे इसी से काम नहीं चलता है, ठीक है, अभी आगे आएंगे तो और पता चलेगा।
ओके सर।
आपको तो सबसे बड़ी एक इम्पोर्टेंट चीज हम लोग देते हैं ना, आईपी एड्रेस, वहां तो अभी हम पहुंचे नहीं।
यस सर।
ठीक है, चलिए, तो let's start the discussion about the another device, which is L3 device. And whatever I'm telling about devices right now, in previous lectures also, these all are LAN centric, means we are talking about a local area, maybe a bigger local area network like our institute, but we are not talking about wide area network, like from here to Lucknow, here to from Allahabad to Delhi. This type of network we are not discussing. So we are discussing devices which are commonly used in a LAN environment. Fine. In WAN, maybe the name, again, router is also a L3 device, layer 3 device, and L3 switch is also there, which takes decision based on IP address, and IP address is a network layer address, so that's why it is known as L3 switch. So right now our discussion is more concentrated, more aligned for L3 switch rather than routers which connect one big network to another big network, or in WAN environment, wide area network environment, that router is a different thing. But generically we say it's an L3 device. Now let's focus on IP address first, and then only you will be able to understand the L3 device IP address. So what they have done initially, they have thought about when this internet was getting evolved, they have decided about that worldwide, and I'll tell you IP address came first and then came MAC address. As I have already discussed, worldwide we require a unique identity for the device. So they thought about IP address, and here we are discussing IP version 4. So what they have thought that we will be having 32-bit address, and using 32-bit address we can connect 2 to the power 32 devices, and at that time these 2 to the power 32 was considered very big number, and they haven't thought that in 1994, in early 1992, they will start experiencing scarcity of IP addresses. And I'm telling about the time when subcontinent was not connected to internet, and after subcontinent, our China, India, and all these countries are connected to internet. We can think that there is huge scarcity, and then we have switched from IP version 4 to IP version 6, which is 128-bit identity. And we are not only talking about Internet of computers, we are talking about nowadays Internet of Things, that everything would be having an IP address. So that's another story, but let's stick to 32-bit IP address. And what they have done, they have divided these 32 bits into 4 octets, 4 8-bit divisions. So it's like, and then they have converted these 4 8 bits into decimal number, and that's why you see IP address in this form, 172.31 dot. So dotted decimal notation, 100.14. So this is dotted decimal notation of IP addresses. Fine. So 32-bit in 8-bit 4 groups, and each group can be converted into a decimal number. And then this is the method we represent the IP address, something dot something dot something dot something. Now what they have done apart from this is, depending upon the situation at time, they have divided this 4 dotted decimal into 2 parts. So one was network identity, and other was host identity. So which network you belong to? What is your network identity? And within that network, what is your host identity? And then they thought that, okay, because depending upon the condition at that time, what they have, just let me take this call. नितिन क्लास में है अभी
सर नमस्कार
क्लास में है अभी 15 मिनट
अच्छा,
बाद
ठीक,
ठीक ओके
सर।
ओके okay so they said that let's divide these IP addresses into some classes. Class A and then class B, class C. There are other classes also, but let's not focus them right now. So what is class A? Where they said that the first octet would be giving you network identity, and rest 24-bit would be for host identity. And there was a reason behind that. What they have thought about at that time, that there would be a small number of companies which would be having large number of hosts. So means 2 to the power 8 bigger network can be theirs, each having 2 to the power 24 hosts. And then they have fixed some of the bits, initial bits, and those bits, I don't remember the exact bits which are fixed for class A, class B, and class initial bits which are fixed for class A, class B, and class C. I don't remember the exact bit, but some initial bits are fixed just to recognize whether this is a class A IP address, class B IP address, or class C IP address. So there would be, what they have thought about at that time, there would be smaller number of companies which would be having these many number of hosts, the requirement of these many number of hosts. The class B IP address, where network part is of 16-bit, and each of this network can have 16 to the power 16 bits. 16-bit host part means 2 to the power 16 networks can be there, which each can have 2 to the power 16 hosts. Obviously not 2 to the power 16 network, because some of the bits are going to be fixed. That's what I was telling. Not exactly 2 to the power 8, because some of the bits are going to be fixed, just to identify whether it is class A, class B. And then they have thought that there would be large number of companies, 2 to the power 24 minus some bit, if you reduce some of the bits, 2 to the power 24 companies which would be having 2 to the power 8 hosts each. So this was the classification of IP addresses at that time. But major takeaway from this discussion is that every IP address is going to have two parts, network part and host part. Now it's just like a hierarchical mechanism which we have in our postal system. So if you see my address would be Mayank Pandey, Department of CSED, Computer Science and Engineering, MNIT, Allahabad, Telierganj, MNIT, Telierganj, Allahabad, UP, India, so and so. So if somebody is sending me a snail mail from Japan, so how do you see my address? You start looking Mayank Pandey from Japan? Yes or no?
No.
No, obviously. So you'll be saying this, no? So let's send this letter to India. Now when it reaches India, you'll be sending to a Grand Port Office of UP. When it reaches UP, you'll be sending it to Divisional Post Office of Telierganj, and then from there it will reach to MNIT. From MNIT, internal dark system will send it to CSE, and in CSE there is a pigeonhole by my name, and my letter would be dropped here, where the name is MP is there, and then I can pick my letter. So there is a hierarchical arrangement, and similarly, whenever you want to transfer packet, you go and see the network part. So all these routers on internet, all these routers which are interconnected, they store the network identity of the IP addresses, network part. So the data will be routed based on the network ID. Once it reaches the final network, then only the host part is needed. That in this network, which host I need to transfer. And that is how the whole internet is designed. So let us put a break on our lecture right now, and then in the next lecture, I'll first of all explain the internet architecture, the hierarchical architecture of internet, and then slowly and gradually we'll begin our discussion of IP address and use of IP addresses, data forwarding, and things like that. If there are any questions, you can ask, otherwise we can leave.
So when we get a proxy address from our college, isn't that like we're getting a new IP address?
No, 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 no.